All right, well, I think this is a good time to get started. There's just so much to cover today, and I'm really excited to have our guests on from Nexa 3D as well. Again, welcome to today's webinar. My name is Greg Paulson, and we're going to be talking about from sketch to SKU, developing XiP, the world's first ultra-fast 3D printer. We're going to be focusing on the product development of the XiP, and we're going to have our team members on board. Before we jump into introductions, I do want to go over a quick agenda about what we're going to be talking through. So I'm going to talk a little bit about Zometry, after we introduce our folks. Then we're going to talk about Nexa and what Nexa is working on in Nexa 3D. And then we're going to go through the story of the XiP and some of the product development goals that we had. And we've highlighted three particular case studies around that. And we're going to have a discussion-based conversation about the product development, running the challenges along those product development fields and how they were overcome. At the very end, we'll talk over some more resources that we have. And we're just really excited to get going. So let's take a look at these friendly faces here. I'll give a quick introduction myself. First off, my name is Greg Paulson. I'm the Director of Application Engineering at Zometry. I wear a lot of hats. I've been a buyer, a designer, a supplier of manufactured parts of all shapes and sizes. And I've worked as professional in additive manufacturing for about 15 years, since 2007. I've run machines as well as been part of the procurement and even validation side in additive manufacturing. And I work with customers, and I succeed vicariously through them, working through Zometry through thousands upon thousands of projects. I now also want to introduce the team at Nexa 3D. We have two awesome engineers here. Let's start with Eduardo Reveles, a mechanical engineer at Nexa 3D focused on the XiP desktop MSLA printer. Eduardo holds a BS in mechanical engineering from the University of California, Riverside, and has been with Nexa 3D for about 3.5 years. Hey, Eduardo, how are you?
Hello, Greg. Thank you for having us today.
Absolutely. And yeah, joining Eduardo is Kenyon Wetzel, the Director of Mechanical Engineering at Nexa 3D. Kenyon has been with the Nexa team for over 4 years, has worked as a mechanical engineer for Haas and a product engineer for DP Technology in his previous roles. Hey, Kenyon.
Hi, Greg. Hi, everybody. Yeah, just want to say, welcome and thanks everybody for joining us, and thanks, to you, Greg, and the Zometry team for having us here. We're definitely really excited to talk about Nexa 3D and the XiP project.
Absolutely, yeah. It's so funny when we talk about this. Like, I always wish we record our prep sessions because it's just geeking out, So we spent, as we were preparing for this, there was just so much geeking out back and forth, and we're distilling it to some of the core concepts. But it's always really fun to prep with engineers. Some notes though before we begin. We love answering questions. We live in context. On the GoToWebinar platform, there's a questions and answers form or field that you can fill out. Please use that to answer any questions. We will be monitoring these questions as they come in, so please submit them anytime. You'll also be able to get a recording of this webinar after it's over. So we usually email those out a day or two after the event, and that's something that you could go to rewatch the event or share with your colleagues. And stick around though to the end of this event, because we will have some discount codes and offerings. So I know Zometry, we have a discount for our services, and a really fun thing, Nexa 3D is also has a Rook giveaway. So their X Rook design, they'll print some out on the XiP 3D printer and send it to you. So we'll have some information about that offering at the end here. So I'm going to jump in, tell you a little bit about Zometry, and then we're going to get into the main discussion here. Zometry, we make a lot of parts. We've been open since around 2013. Had some really exciting news in 2021 when we went public over NASDAQ for XMTR, but we serve over 30,000 active buyers. And we also connect those buyers with over 10,000 active suppliers. Zometry is a digital manufacturing marketplace, so we're able to make the aspect of sourcing and fulfillment very, very simple. Zometry is also connected with ThomasNet, so we acquired ThomasNet last December, which expands us out to even over 500,000 supplier bases. Our goal is to be the first place you go to get custom parts sourced, period. And we offer full managed manufacturing services. What is a digital manufacturing marketplace? You know, it's something new, right? Zometry kind of invented the field. So I always like to bring this slide up to go over the concept. Along the way, there's been very established industries. You know, they're around everywhere when you think about travel, auto, transportation. And what we've seen in the last couple of decades is a digital disruption. Whether it's be Airbnb for travel, or what Amazon has done for the retail services, or Uber or Lyft for transportation. And when you look at manufacturing, that gap was also there. There were people who needed stuff made who didn't know the right suppliers to make those parts, or didn't always have a full list. They weren't omnipotent in their abilities. And the same thing with suppliers. Suppliers are typically working local to local, and they may be perfect for that group out in California, but they're in Utah or they're in Virginia, and they may never have that connection. Zometry came in and built a platform that allows buyers, people who are looking to get something made, to very easily configure and get pricing and lead times. We call it our instant quoting engine, where you can upload a 3D model. We actually use AI and machine learning to provide pricing and lead times, and we're offering our 17 manufacturing technologies through our instant quoting engine. And we also have that same platform for the supplier side. So they have something that we call Work Center that allows them to take a look at work that is specifically paired up with what they're great at. So suppliers are able to see work on demand that's relevant to their project needs, and it allows us to have massive supply chains managed through technology. So it's really a win-win, giving accessibility and kind of democratizing manufacturing for everybody. So what's the relationship with Zometry and Nexa 3D? Well, like a lot of our large customers at Zometry, it starts with a few parts. You know, usually engineers like Eduardo will find Zometry to get something made, whether it's a rapid prototype or something where you just have a CAD file, upload, get a price, looks great, press buy. And we grew from there. Nexa serves multiple industries, being a 3D printing OEM. So whether it's consumer products, medical devices, dental products, or even university labs, this is their industry overall. As an OEM, when they're producing this electromechanical system, those mechanical components became Zometry work. We essentially work with them on creating and producing those items, whether from the rapid prototyping stage or into the saleable production units. And we're going to talk a lot about that today. But you can see the services utilized are pretty comprehensive, whether it's machine parts, molded parts, some sheet metal components, even extrusion came along with them. And I didn't even put, I have rapid prototyping, but I didn't even say like 3D printing services there. But there's, through the gamut of product development, Zometry can be a consolidator for just getting stuff made and stuff done. Nexa released XiP, which Kenyon's going to talk about in just a moment here, that fits a market where they're looking for a professional desktop SLA style printer, and to bring it to market with aggressive lead times, they really need the right manufacturing partner. And what Zometry was able to do was use our platform. Like I said, it starts with that click, drag, and upload of a file, but we were able to show and prove ourselves that we can move with them whatever their scale requirements are, using our professional teams of engineers, as well as our expansive platform through Zometry. So let's get into the details. Let's get started, and I'm going to pass the mic over to Kenyon for a little bit. Just tell me about Nexa. Like, what were you looking to achieve, and tell me more about the XiP.
Yeah, thanks, Greg. So, a couple years ago, we launched the NXC 400, which was really the first product to the market utilizing our LSPc technology, and I'll talk to that a little bit more in a moment. But with that product, we were able to give our customers really unprecedented speed and productivity for a photopolymer 3D printer in this class, more than 6 times faster and still having industrial level accuracy and tolerances. So the XiP project was all about taking that printing speed and quality that we've had in our flagship NX printers and scaling that functionality to a package that would be accessible to a broader audience. So, not only industrial and manufacturing, but also offices, engineering, dental, tons of possibilities. We wanted to develop the first desktop size machine that would be straightforward to use, offer that industrial level productivity, and really be a no compromises product all around, which I think is really unique to the market. And I think it's worth pointing out, we did this all in less than 18 months during a pandemic. So all those normal supply chain challenges aside, we knew that having the right partners would be critical to a successful outcome.
Yeah, and I really like your statement of the no compromises either. This is a professional system that fits on a desktop is the best way to say it. And I've worked with professional SLA style systems or DLP style systems, and I've seen the miniaturized versions, right, the desktop versions, and usually the compromise to get that small is mess. It's like, yeah, the function's there, but everything you have to do, the prep and clean on afterwards, is often a very manual and very messy, sticky task. So let's jump through some of the tech specs really quickly here. And by the way, like as I said, for anybody who wants more tech specs as well or has any questions, the Q&A tab, please use that and ask questions along the way, and we'll be able to follow up at the end of this presentation as well.
Yeah, so kind of going over the tech specs here. 4.8 liters of build volume, and speed, of course, is really key to this product. Up to 18 centimeters per hour. As an engineer, and I'm sure Eduardo could attest to this as well, this is pretty huge, right? Prior to Nexa 3D, I was accustomed to utilizing 3D printers for a prototype maybe once a day, but with printers like this, we can get prototypes, iterations, 2, 3, sometimes 4 iterations in our hands in a single workday, which of course helps developing products like this that much faster for ourselves. And of course, looking beyond prototyping, actually across many of our current product lines, there are instances where we've opted to print various components for production. So the size and speed we're talking about here is certainly more than capable of manufacturing demand when needed.
Go ahead.
Resolution as small as 50 microns. You can certainly get all those finer details and accuracy, the tolerances that you need. Of course, it's based around that same LSPc technology found in the NX printers. This product in particular has a lot of unique and valuable user experience features, such as a resin delivery cartridge that we'll explain in a bit more detail. And very importantly, it's priced very accessibly, under $6,000 US.
Yeah, and like I said, I like the I like that your suitability score is also office, and it's really interesting because when you move from a factory where factories may build out places for post-processing, but when you are designing something for office and consumer environment, and we're going to talk a little bit more about some of those considerations, but like I said, you really do have to make the kit and the user experience very, very accessible. So speaking of, let's talk about this. You have been tasked, T minus 18 months to bring something to market, and this is going from essentially like truly concept to a commercialization effort here. This is going to be, we're going to talk about 3 specific items as we go through this, because they each highlight a different requirement and engineering challenge related to them. But know that Zometry, we work with you on a multitude of this. Most of the mechanical items that you see in the XiP were produced through Zometry in our supplier network. So we've had a really great relationship and experience along the way with you all. But yeah, let's start off with the first example here. So let's talk enclosures. Tell me a little bit about this, and Kenyon, I'll start with you, and we'll talk about the engineering, the technicals in a second here with Eduardo. But what did you have to start with, and what were the goals when you talked about the look and the mechanics of the enclosure?
Yeah, so we talked about some of the stuff inside, but the form really needed to suit that industrial nature and functionality of the machine. so that it could be equally at home in an office space or maker environment as it would be in that full-scale manufacturing environment. We worked with industrial and product design teams, our industrial and product design teams, to arrive at these concepts that you see here. These are some of the sort of early renders and concepts, so that it would not only have the appropriate build quality, but also that right kind of look and feel commensurate of what's inside. And you know, it's important to note also that as an organization, Nexa 3D is always mindful of sustainability as one of our core tenets. We're a member of the Additive Manufacturing Green Trade Association. We're constantly looking ways to reduce or even eliminate our environmental footprint. So we prioritized recyclable or recycled materials and therefore converged on aluminum as the primary enclosure material, since it's the most recycled material on the planet. But it still allowed for that build quality and robustness that we needed and that our customers wanted. You know, as I'm sure a lot of engineering teams and you know, a lot of the engineers who are on this call would be familiar with, the product specs we were challenged with were, let's say, a little broad. So something like, you know, make it look as good as this tablet or phone or watch that we've got here. But of course, we didn't have too much of a starting point in terms of how to achieve that surface finish, that surface roughness, etc. But I think our engineering teams and also Zometry, of course, really stepped up to that challenge.
Yeah, and this is fun to discuss because it's making mechanical designs, right, and iterative prototyping. A lot of times the cosmetics, you get to a good enough stage, but you are producing a saleable item and you need to produce it at scale. So it's very different. And I just imagine Eduardo sitting at his desk and Kenyon walking up to him and slapping a picture like this, you know, or maybe just digitally, you know, setting it to him in Slack or whatnot, saying, make it like this. So here's your specs, Eduardo. Just tell me a little bit about the engineering challenges you had. You're making this out of aluminum, and just walk me through that.
Well, Greg, being honest, that's exactly how how Kenny came up to me, and you know, we kind of were aware of kind of what the product team and overall Nexa wanted for this product, and we didn't have much to go off, so we had to, you know, start from scratch. We didn't have much of a foundation, but we started with these aluminum panels, as you see there on the image below, and we tried a few different things. We worked with local vendors, local shops. Like a fun story on that was that we literally were going through every local shop in our county, and we couldn't come to the right solution on that. So I think that's when Zometry really helped us out on being able to, how you explained earlier, that connection with someone out of our county to help us out.
Yeah, and I think this is something really interesting, and I think, you know, Kenyon, we've mentioned this, you know, a lot when we were discussing this. There's a lot of paradigm shifts with what you see Zometry as starting off as an engineer and the way you're interfacing with us, and then what else Zometry can do. And this is definitely one of those first examples of this that we had was, I have a product that one part needs to look this good, but not just that, the parts beside it need to look the same, and the whole integration. And then every time I make this unit, so every single you know, time this is done, it needs to look consistent throughout. And that's where a conversation is handy, right? And I think that's something that was, you know, one of the first paradigm shifts was us understanding that you can talk with Zometry, like where there's a man behind the curtain, because we have a lot of automation, we have a lot in our interface. But when you're looking at the scale and production, it is very different than just a click, drag, upload experience. The technical information is still shared that way, but what else we could do is different. And I think, Eduardo, in this case, we were able to take a look at the bill of material, work to take your communication, so what your goals were, and turn it into specs, turn it into like requirements to communicate to our suppliers, as well as look at all the parts that had to have that look, and create create a templatized way of repeating that. So that is, to your point, like I think you mentioned you just got in a car, right? And just started driving, driving around, which I think if anybody's in product development on this call, we've been there. Like, we've been there. We've been there. Like, I've always been on those runs too when you just need to get something to ship that day, so you're just kind of waiting outside your finisher's parking lot until they're done, and then you go and pick it up. And this is one of those moments. Is like I need a solution. But with Zometry, with the reach that we have through our network, as well as our manufacturing suppliers all around, like we have manufacturers in 46 states here in the U.S. and then also a global manufacturing network. We've been able to expand that. So, these are the final results, right? This is the XiP launch, and hey, there's Eduardo there. So this is your launch at Formnext, is that right?
Yeah, that's correct.
Yeah, and you can see when we talk about these machine components, all of this is CNC machined. So the fan vent area, the pieces of the door, kind of that wraparound feature that goes around the front and back of the unit, as well as curling up to the roof there. All of that had to have a consistent look, and it's something that we were able, again, to have that conversation, reach into our network, and build those requirements to achieve that goal. So the next example that we have, and each one of these we're hoping to frame in a different way, is this build plate. And this is actually, again, I think an awesome example of like what happens in reality, what happens when you're in production and when you're really manufacturing. So before we get into those details, though, I think it's really important to understand why these requirements are, so important. And Kenyon, like, walk me through, the design and why the build plate is just so critical to this this machine here.
Yeah, and as you said, Greg, I think it's a great chance to take a little step back and speak a bit about the background of that LSPc technology that I mentioned and Nexus technology overall, because it'll help provide a bit of context on why this was particularly challenging for the engineering teams and sort of unique for the XiP. So LSPc specifically refers to our membrane technology, which is the interface of the build platform and the print engine. And that significantly reduces the peel forces that are otherwise actually inherent in SLA 3D printers. And that reduction of peel forces is what unlocks a much greater capability of the print engine itself. So more power, better resolution, better accuracy, higher reliability, and of course the faster speeds up to that 18 centimeters per hour, which allow for significantly higher productivity. We spoke earlier about the 15 micron tolerances the XiP is capable of achieving. So it's kind of clear from that to see that the build plate, which is actually the printing surface and its alignment relative to that print engine, is critical to realize the tolerances, ensure the homogeneous material properties, and also get that print reliability that our customers need. So things like flatness of the build plate, parallelism to the build surface, those are all very key in realizing those. And actually, we had really good success with the pre-production units just before going to launch by aligning each build plate itself to the machine. I think Eduardo and the rest of the engineering team did an awesome job. Maybe a bit too good, because Eduardo got thrown a bit of a curveball by some of the late, sort of feature and requirement changes by our product team, which again, I'm sure engineers on this call might be used to. But I think it worked. It worked out in the interest of providing ultimately the best possible product for our customers.
Yeah, and so what was that requirement change? Like what happened? And I guess Eduardo, my next question is like, when did that happen in the development cycle?
Yeah, I think the interesting part on that was that we had already, finalized the designs for the build plate. Zometry the whole time had our designs with them, and like Kenny mentioned, we were having successful prints. It was meeting the flatness callouts, but I think the product team came to us very last minute to add this feature that I think is very useful for the user herself, was to make these build plates interchangeable. So the build plate won't be stuck to one machine, and the part that really helped us out was Xometry was able to be very reactive on that, and we were able to, you know, ship them out new designs very late in the game, and they were able to react to that and assist us in those.
Yeah, and this is where on our side, again, what typically, you know, in a typical state, if you're doing a low volume work, a lot of times that is fully automated. So, you know, if I'm building a dozen items, you know, I could go press order, and honestly, within 24 hours, your parts may already be started. They may already be running. At this point, we've worked with you through iterative prototyping. So as Ken, you mentioned, we had design iterations, we validated the design, the tolerances, you know, the precision, fit. And then post PO, this is a, you know, kind of almost an ECO, like engineering change order, right? Things are in production, and we had a change. What that looks like from our side is, first off, like, you know, we have a way of communicating, right? So whether it is through your sales lead or talking directly with a case manager if you've already been in collaboration with them. And I think in this case, we already set up a Slack channel with you all, right? So we actually sometimes we work with what we meet you where you are, right? What's the best way to communicate? And I don't say every job has a Slack channel, but I'm saying that when you're in production, you know, where our goal is to just be there right with you, you know, be a true partner with you. And yeah, what we see on our digital landscape is those new technical files. We're able to contact and flag via our work center with a supplier, you know, any potential changes, and kind of get them to a point where we see where they are, and get files revised on the digital platform, review any changes needed, and make those outcomes. And this is a great example. It's not an everyday example, but again, when we work from production, it's a partnership, right? It's a little bit different than just the regular iteration. It's something, you know, we're able to do and make that and achieve that. And again, for you, it's all kind of white glove service, right? Like, our team is handling that. You just give us the new revs, and you know, we work that out. So really happy we make that change. And I think to your point too, building an interchangeable build plates on this design, you know, I've seen the XiP, and I've seen a lot of people look at the XiP as actually a I'm not going to say a farm piece, like for a 3D printer farm, but I could definitely see that, like, how ideal it is to have multiple of these units and being able to exchange trays out and put them in the cleaning stations and work through your product build design cycle without having one tray married to a machine. So overall, like, it's a win-win. We're able to make that design change and incorporate that into our production. And for you all, I mean, it's a more compelling product as well.
Yeah, and Greg, just to add on that and emphasize the importance of how quickly it was for us to get on the phone or Slack messages, rather than, you know, sometimes emails might take a day or two, but in this instance, Xometry was able to hear the problem that day, and they were able to react that day.
Yeah, and honestly, there's businesses behind that, right? You have your suppliers too, and we have supplier empathy. So, you know, it's like, when we know, they know. When you know, we know. So yeah, I'm glad we were able to get that response. So, you know, we talked about this enclosure, and enclosure, again, these are still precision machine goods, and they had a very unique goal where they needed to be consistent across the set as well as cross production lines. We were able to help, you know, meet not just the specs, like the mechanical needs, but also the cosmetic needs, and find a solution for you. We highlight this build plate because the build plate was a very tightly toleranced design. You know, particularly because of everything that the LSPc technology requires for that. And then we also liked kind of the story to show that engineering changes can happen. They're not always ideal, but we're able to kind of go with the punches, because that's what manufacturing is. You know, manufacturing is tangible. It's real stuff, and we're able to adapt to that and leverage our technology platform all the same. And this one's a little bit of what I call like a prototype to production phase here. So this is the resin cartridge. And also, I think, you know, from after talking to you and hearing from you, I really think the resin cartridge is also one of those items that really makes or breaks the user experience. from what I've from what I heard from you. So let's talk about that now. And this is the cartridge. I'll show you some prototypes here, but yeah, Kenyon or Eduardo, let's walk me through the resin cartridge and kind of what it is and what it needed to do.
Yeah, I think you're absolutely right, Greg. It is a make or break, and we knew that kind of going in. I think one of the really great features about the XiP is that it has an open material or resin platform, but we also have this full line of engineering materials, each with pretty unique characteristics, as well as, of course, the thoroughly proven processes to complement those materials. And in the XiP, we utilize this cartridge to provide those. And normally, resins are kind of the dirty side of SLA printing, I think, that nobody likes to talk about. But since we ultimately wanted that best overall user experience possible, our engineering team got their heads together. Eduardo and the rest of the engineering team got their hands sticky so that our customers wouldn't have to. The resin cartridge, I think, ultimately is a really elegant solution to one of photopolymer printing's biggest pain points, what is normally one of the biggest pain points. In addition to the user experience goals, of course, the fill time needed to keep up with the machine's productivity that we spoke to. So performance was an important goal. Cost targets were key once reaching production, since this is the largest consumable associated with printers like this. And we didn't want to pass unnecessary cost off to our customers. We also wanted a wireless technology in the cartridge to kind of handshake with the printer and the job file to make sure that we had the right processes that I spoke to. And most importantly, I think most importantly, reliability was key. We'd heard some horror stories, I guess, from competitor solutions of materials arriving with leaks or spills or maybe even worse. And we wanted to be absolutely certain that this wasn't a possibility for our customers. And last, since we do offer such a broad range of materials, as well as the possibility for open materials, chemical compatibility is actually quite important as well in the final product.
Absolutely. And Eduardo, walk me through that. So you were tasked with building and designing around this resin cartridge. Kind of walk me through your product iterations, where you started, and essentially, and actually, I think there'd be some curiosity of like how many iterations did you really go through as you're building out this design?
Well, yeah, I mean, quickly, you can see on the image below, I think every single one of those caps is a different iteration. So you can see how quickly we had to iterate on this to bring this to production. But yeah, I mean, we do have 3D printers in-house that we could quickly prototype, but how you mentioned, as well as Kenyon, was some of these materials weren't compatible within one another, or especially when they're making contact with uncured material. So we kind of had to go through, in this case, Zometry, and they were able to offer alternative 3D printing solutions, that still met the quality we expect from these designs to kind of keep us moving forward and be able to reach those product requirements that Kenyon mentioned.
Yeah, absolutely. And yeah, we have 8 unique types of additive manufacturing quoting on our site right now. So there's definitely a lot to choose from. I think between all those, it's a ton of materials, dozens and dozens of materials as well. So and each one of those technologies, we are able to still meet you where you are with your timeline. So you could always have expedite options on certain tech, but almost all of these will ship within the week of order. So as you're working through iterative product development, this is something that it's the next best thing to having a printer on your desktop. Which again, I think you're spoiled, because I think that you were showing these ones on the right hand, right, were built with your product, I think, right? And
yeah,
so
that's great.
You're able to get the mix, but I think for the functional prototypes going through, like you're using some of our thermoplastic processes running through. And then, by the way, I love this because this is what product development looks like. Testing, trial, iteration. There's always this fantasy that the first time you try it, it's right. But honestly, if you think it is, it's just hubris. You know, I always think like the first time, you know, if you're building something, and even in my experience when I work on product development design, I will often do a shotgun approach with 3D printing, where I'll go and build, you know, 1, 2, 3 iterations, and literally send all 3 out at the same time on the job, just so I can, you know, test and validate a few things at a time. But 3D printing,
And
you know,
we wanted this to be we wanted this to be perfect, Greg. So yeah, really, this is sort of the tip of the iceberg. And you know, Eduardo knows we would even you know, we'd put these in the mail and ship them to ourselves to kind of make sure that, you know, sort of simulating the full customer workflow, right? And we wanted to do that with as close to a representative product of what would be ultimately molded and things like that at the end of the day.
yeah, I'm adding that to my list, by the way. When I'm testing out a consumer product, is ship it to myself, you know, across the U.S. Make sure it's in a plane and, you know, meets shock and vibe and pressure requirements. And as you mentioned, like, you know, nothing's worse than getting a resin cartridge that's leaking in the package.
The simulations only go so far, right? So
The simulations. And so you go through this iterative product development process. Additive, or, you know, a lot of these technologies can only bring you so far, but you're hitting the masses. So you had to pivot to a production grade technology. In this case, what made the most sense was plastic injection molding. Can you walk me through that? So you've kind of solidified your design. Tell me about your experience moving with molding. This, you know, Zometry, we provide the molded products. I have to say that, but yeah.
Yeah, so I mean, Kenyon kind of touched on it earlier, but one of the kind of points we had to go across was, you know, as we were iterating on the prototypes, we had to, you know, have production in the back of our head. And I think very helpful part from Xometry was that we were able to work in parallel with them to start DFM changes for the components on the cartridge to get it to an injection molded design. So I think that sped up time because we didn't have to speak to a new vendor, you know, and start the whole process from scratch. I think Xometry was with us throughout the whole time, where, you know, they knew what the components looked like. They had printed them before, and now it was just to get to that production phase.
Yeah, I've done whole presentations on what I call the parallel path, which is something that's unique for Xometry. We greatly we not just enjoy, we live, like I said, we live vicariously through the success of our customers, right? Just like Nexa, like everything that we've done, like, I mean, we're proud of the work that we were able to achieve, and honestly, the designs like that you've made are amazing, and we want to always, you know, build parts to the quality. We always want to build that relationship and know where your parts are going, if at all possible. So in this case, somewhere along that product development lifecycle, we understood that these iterative prototypes were going somewhere, and we started to have that conversation with you about, you know, what are your goals and what else Xometry is capable of doing. And a lot of times I see that with 3D printing, where you see exactly what I'm going to move back to the previous slide here, that highly iterative, like, you know, once or twice a week, a new design's coming out. And then at some point you see 3 or 5 or 10 of the same design. And a rev's starting to get locked in. You know that revision is starting to solidify. And that's great. And that's a lot of times when you move the mold. But what we've seen is the earlier we get in that conversation, the more that iteration becomes more and more tuned to the final process, because 3D printing very often can achieve that geometry that is also moldable, like, you know, adding uniformity, undercuts, draft, just making sure that all those things are there. Because when we move to injection molding, you know, we work with you on other things, like how are we going to approach the tooling setup, parting lines, ejection areas, gating strategies. And if you already have that design solidified and kind of tuned out in the prototyping phase, it helps speed up that go button. So it's not a go, then stop, rev change, add drafts here. It's a go. We talk about the technical tooling requirements, and we're cutting metal and making molds. So can you ask for this? So I actually exchanged a picture right before this presentation because I think this is the sense of pride, right? This is your goal, like a package going to the customer. And this is, something that we worked with you to achieve. And, we built, I think over 80% of the mechanical bill of materials that went into the XiP, like this ultra-fast desktop 3D printer. And, in collaboration with Nexa, as being your production partner, helped bring that to market from literally that, make it look like this brushed aluminum or this, this bead blast aluminum, and here's my industrial design files, to a box product going to a customer in 18 months.
Yeah, and in retrospect, maybe we should have called it kind of sketch to print, sketch to SKU. I like the title, but I wonder if we should have called it sketch to print. I think ultimately at the end of the day, we're not happy unless our customers are, once they're printing, that's when we're satisfied, right? Once they're satisfied. But certainly throughout this whole project and working with Zometry is a really unique. They're really unique compared to other manufacturing vendors that I've worked with and that we've worked with. But likewise, I think Nexa 3D isn't exactly a company that I'd call a conventional manufacturer either. We get really excited when we have game-changing technology or developments that we want in our customers' hands as quickly as possible, so that they can realize the value of those innovations. And of course, having the right partners who can keep up with that pace is difficult, but also essential to that point. Certainly, as Eduardo noted previously, when we're developing products at Nexa, our printers are certainly capable of providing the printed prototypes and production parts and some production parts, but every technology has the right use case, right? So, we'd had some prior familiarity with Zometry, and we'd utilize them for things like prototypes, quick turn parts, and they excelled at that. No complaints, certainly. We'd also used Xometry's auto quoting engine to make those, getting those R&D or prototype parts quick and easy for those purposes. And Eduardo, I think we've all done the same on the engineering team, kind of using that auto quoting engine to confirm some of our own estimations or assumptions when designing for cost and manufacturability, things like that. It's pretty powerful for that. But while developing the XiP project and working with Zometry, Zometry really challenged our assumption of those capabilities and showed us the value of their domain expertise, their in-house capabilities for production, that were a good match to what Nexa 3D needed for our customers, right? Matching that pace of innovation and scaling a product like this.
Thank you. And I think something else from a corporate and social responsibility standpoint, I think Zometry and Nexa really did mesh with our environmental initiatives. There's a lot of responsibility, especially being a manufacturing marketplace. We're connected to over 10,000 suppliers, doing I don't know how many, hundreds of thousands of manufacturer projects, and those are shippable items. Zometry started its Go Green initiative a couple years ago, and something that we do is for every shipment. So anybody who's on this webinar who's ordered parts and had them shipped by Zometry, we've already offset the carbon footprint of that shipment. It's something that we do courtesy within our platform. And as a marketplace, it's really unique because if you ask all these individual suppliers to say, hey, can you offset the carbon footprint? They'll be like, how do I do that? Where do I start? So being a marketplace, it gives us a little more leverage to show those responsibilities and implement programs like that. Even within our interface, there's actually options to offset the manufacturing so that you can actually volunteer to do offsets for forestry, wind, or solar. And so far in counting, we've offset over 6 million pounds of carbon dioxide within the launch period of this program. So it's been very successful as we're going along. And a part of that is just because it's built in, it's a built-in program. And I think, talking with Nexa and Avi, that's something else that is a big focus there. So I mean, you mentioned AMGTA, so you're part of that consortium and working on recyclability. And you also, you guys invest in forestry as well, right?
Yeah, I think this is another reason why this was a really good match for a partnership on a project like this. One of Nexa 3D's core tenets, actually the core tenets of Nexa, is to digitize the world's supply chain sustainably. And there's a number of ways that we've incorporated that commitment in the scope of this project when developing the XiP. First, it's a super efficient machine, right? More than 80% of the power consumption goes towards the actual printing process. We spoke about that, the recyclable materials, including the aluminum enclosure. And we have somewhat of a similar program, similar to Zometry's initiative. We offset our impact by planting 10 trees for myself, for Eduardo, for every employed Nexer, we call them, as well as 10 trees for every XiP that's sold. So actually, to date, we have planted well over 3,000 trees and counting since that program started.
So you have Nexers, we have Zommers, or sometimes when in the season we're zombies, if it's Halloween season here. And by the way, this is a great time. We're about to get to the question and answer. I've got like one slide to go here. If you have any questions, please feel free to type them into the questions tab. We have live Q&A. We love talking context commentary. Feel free to ask us anything. And we were talking about the instant quoting engine. I really wanted to focus on the engineering stories, but this is a free tool. Xometry.com. When you could go and click get an instant quote, upload your 3D CAD file, and you can see pricing and lead time over a variety of different manufacturing disciplines. And we're not just making shapes; we're making parts. So beyond just the part design, you could go and further specify threads, tapped holes, added inserts, certifications, inspection requirements, finishes options, multiple finishes, you name it, and you can actually go and I call it building your love letter to your manufacturer, right? Specking out on the Zometry page, and you'll see your pricing lead times dynamically update. Even though it's not something that you see directly. So Eduardo is a really good case when we talk about the aluminum housing. It's not just bead blast, it's not just anodized, right? It has a higher level requirement to it. You can write in your requirements. Excuse me. You can write in your requirements, and that custom field will move to an engineered quote, where you can submit that engineered quote. It goes to our internal team of experts who are able to go and review that. And typically, we're turning this quote around within about a business day or so. So even when it's the manual side of it, we don't mind that. Actually, we really like taking a look at these projects, and when they have special needs, they have special needs, and we're able to handle those as well. Last thing is that if you do have SolidWorks, if you use Onshape, if you use a Fusion 360 or Inventor, Zometry has free CAD add-ins available. So we meet you where you are in your design environment, and some of them have built-in DFM and other tools available. And we are up to 17 manufacturing technologies. So the traditional machining, sheet metal, sheet cutting. We added tube fabrication, laser tube cutting, sheet metal scaling up. We have stamping, CNC machining scale up. We have die casting, or you can use extrusions to save some operations. And under additive alone, it's eight unique additive manufacturing processes and counting. So again, our goal is to be the first place you go to get custom manufactured parts. So on that note, I think it's time to move to some Q&A. And again, please feel free to add some questions as well as we're talking along here. And I think we have a few questions already. I also want to highlight that if you want to try Zometry for the first time, we have a discount code, which is this. It's not, wow, I thought it was to try, but I know just read it in your mind here. But that's a discount code that you can use to save $25 on your first order. And also, I put a QR code up here as well. So if you want to see what type of part the XiP produces, I may actually do this as well right after this event here, because I want this really cool rook. So you can scan the QR code to get the XROOK printed through the XiP platform. So I have a question that for Eduardo. I think this is a good one for Eduardo. You know, what's the favorite feature that you designed on the Zip?
I mean, I work mainly on the enclosure, so I'd say I'm very proud of how it came out, and you know, I think it's pretty pleasing to look at. But one of the cool features on the Zip, I think stands out to most people is the vat. It contains some electromagnetics on there, so it's a toolless attachment. So I think that's very cool. It really, you know, contributes to that user experience we want to offer our customers, is to be able to just slip in the vat and be able to attach, you know, without having to twist or turn any levers, any cams. So I think I would say that's probably one of my favorite features on the Zip there.
Yeah, and that's you're talking about the vat. That's going to be like it's a machined component, and it has the window
Holds all
on it,
the
right?
resin.
So, yeah, and
Yeah,
with the
yes.
resin. Yeah.
Yeah, so it holds all the resin, and you're able to just slip in. You know, most printers usually have some sort of like lever that you have to turn, or you know, some thumb screws, and this one just kind of snaps on. So I think that's a pretty cool feature on the Zip there.
Yeah, I appreciate that too. So we had a Zip up over at our booth when we were at IMTS in September, and that was the most accessible piece other than the build tray for me to just show a machine component, because I would just reach in and pop it out and say, like, you know, take a look at this component there. So it was so intuitive, I didn't think twice about it, which means it works, right? Like the best engineering doesn't require an instruction manual, and
Exactly.
I think that's great. Speaking of materials and the Rook here too, you know, what type of materials is a Zip printing? Like, what, you know, tell me a little bit about the material portfolio that you have.
I can take that one, Eduardo. Yeah, you know, I think one of the cool things about, you know, again, I noted the open material platform, but one of the cool things I think about the materials that we have those proven processes and parameters for is that all of those are actually collaborations with the world's leading material suppliers. So that includes Henkel, BASF, Evonik, Arkema, and you know, really whatever you're looking for, engineering grade materials, high temperature materials, flexible materials, super fast prototyping materials, for example. And that's kind of just scratching the surface. You know, you got the mechanical engineering team here, not the sort of process and applications team. So I'm maybe not the best one to speak to it, but I definitely encourage you to, you know, visit our websites, and you can kind of get the full rundown of materials.
And I cannot understate that in the last 5 years, it's been a photopolymer renaissance of just what has, like, night and day. When you used to think about photopolymer printing, you're like, looks pretty, very brittle. And now you know, I've worked with several materials, several examples where the resins are engineered. Some of them have like secondary stage curing. Some of them, you know, other like dormant materials within them activate. So like the acrylate will cure, and then something else will go and essentially replace it with better longer term mechanical strength. A lot of items are much more UV stable for long term use. So it is just absolutely amazing. And yeah, not even mentioning the rubber elastomers and other resins that give you flexibility. I mean, it just didn't exist, or didn't exist well. Everything felt like fruit roll-ups, you know, for the longest time. So
yeah, I mean, you know,
amazing.
since launching the NX printers, and even since launching the Zip, we've seen so many cool examples from customers of using these engineering grade materials for, you know, production parts. You know, literally printing production parts. You know, I think it's much beyond the prototyping that I think a lot of people have an assumption about 3D printing for.
Absolutely. I got one last question. Let me double check to see if we have any more questions coming in here. But yeah, if anybody has any other questions, you know, you got one last shot. Let me see here. All right. So, yeah, my last question was that it's actually about Zometry and just how to request those productions. And I think this is a really good question, because our quoting engine has a lot of automations built into it. We do have, like, as soon as you start building a quote, you will find out who your direct sales point of contact is. So you usually get an email from one of our sales leads with introduction. They're your sword and shield. So a lot of times when you're having a question, when you're trying to build up and say, hey, this is beyond just a prototype, or this is a prototype now, but here's where we want to go. That team member is going to be the first person to work with to build that relationship,
Thanks, Joe.
through. Oh, okay, sorry.
I said thanks, Joe.
Oh, is Joe on there? Oh yeah, Joe. Oh, Joe. Yeah, Joe is your rep, and absolutely. And by the way, I bugged Joe a lot about before this webinar, kind of debriefing too, because they learned everything about the project, right? They're really built and committed. Some other ways, if you are the first person or first time quoting, if you want to trigger that conversation, you can kind of cheat in our system, which is choosing custom on either material or finish. We'll build an override to go to request manual quote. And that's where you can actually add in notes or add in your finish a specific need. So again, Eduardo, if you were talking about the cosmetic faces and this is your first experience with Zometry, and you know the auto quote's good, but you want to make sure they really know. You could go into finishes, add a finish and talk about a cosmetic specific requirement. You could even in the notes field go and add that like that graphic, right? Like what I'm trying to achieve here. And that'll actually go directly to our engineering team to solve that.
Yeah, exactly. And yeah, I think we already mentioned Joe's name, but exactly like you said, there's a face behind everything that we go through on the Zometry website. So at the end of the day, we could only, add so much detail on there. And, soon after we would get a call from Joe, or we would bug Joe to, make sure he understood exactly what we want to achieve.
Yeah, absolutely. And actually, I got a couple more questions rolling in at the very last minute here. So thank you all for that. First off, like a good call out, fruit roll up elastomer, best description I've ever heard for photo elastomers ever. Thanks, Paul. Yeah, I have the unique opportunity. Like I said, we offer 8 different technologies, and we also vet a bunch of different technologies. I'm actually kind of like squeezing a photopolymer elastomer right now as we're talking, and yeah, I try to turn everything into layman terms, and I've fully handled 10,000 parts, so it helps with that. And honestly, I cannot understate how much advancement there's been in photopolymers. So just a question about someone's asking about more information. Where can I start? Starting from scratch. After this webinar, we're going to send some more information out, including some of the promotions and items, so you get more information on the ZiP and even like the promotion for the XRook. From Zometry side, we are chock full of resources. So if you go to Zometry.com, you could click on our solutions and see every single process we offer has a page, and on those pages you could learn more about the process, the whys, the materials, and when to choose. That's what's really important. It's like we have choices, right? We represent the entire manufacturing industry, not just like one thing or another. So we have a lot of strengths and trade-offs as well on those pages. Also check out our design guides. We're chock full of free design guides available. So if you're designing for a specific process, you can actually find a specific guide on that through at Zometry.com's website. And let me see. And yeah, and I think that is it. So any last words or fun facts, Eduardo or Kenyon?
Just, thanks again for having us, Greg. Thanks for everybody for being here. Appreciate listening to us about Nexa 3D and the time today. Thanks.
Absolutely. And thank you too. Honestly, I mean, first off, for being fantastic customers of Zometry, and I've just, like I said, we live vicariously through your success, and it's been a really, really exciting project that we're on, and we're continuing to work with you as a production partner on, and being able to share these stories. I mean, these are, whether you're, you're an OEM doing a production line of a desktop 3D printer, or you're starting off with your very first project, I think it's really important to show and demonstrate that changes happen, adaptations happen, iterations are a must. and there's a lot of tools available to help out, including tools from Zometry and maybe even a zip printer. Thank you all again. Oh,
Thank you,
one
Greg.
more.
Oh, maybe one more fun fact, Greg. Really,
Okay.
it's the engineering team who, they sort of identified Xometry early on. It's I got to thank the engineering team here for doing the hard work of developing the zip, but also really making this partnership and happen. So thanks for that.
Thank you all. All right, take care, y'all. Thank you so much.